notes out. Up until this point, we've only talked about angles in terms of degrees. An angle 60 degrees. We say an angle 90 degrees. Okay, but that would be like saying you can only measure things in inches. Or you can only weigh things in pounds and that's it. Okay? So how there's different ways to measure things. You can use feet, inches, meters, millimeters, centimeters, miles, kilometers, or there's different terms of measurement for weighing things like grams, pounds, ounces. There's different ways to measure angles. So other than using degrees, there's a different way to measure how big an angle is. Okay? And that's what we call a radian. So we're going to talk about how to find the radian of an angle and how to convert from radians to degrees. And we can use the fact that all circles are similar. Every single circle is similar. Just make a circle bigger and make a circle smaller, and it'll match up. And now that we know that circles are similar, we can kind of apply this in the next problem. So here we have two circles. In this example, they both have a central angle that's 60 degrees. But they have different radians. One's 5 inches, the other one's 8 inches. Okay, but we're going to do the same steps in both. We're first going to find the arc length of this circle. So exactly what you should have done on your quiz. You take the measure of the arc. What's the measure of that arc?
60.
60, very good. Central angle and arc are the same. So you're going to say 60 over
360.
very good, 360 times. When you're finding arc length, we multiply that by the what of the circle? The circumference. So 2 pi times the radius. Well, what is our radius? 5. Okay. Clean it up. Keep that fraction the same. You can simplify it or just leave it. Doesn't matter. What's 2 times 5? 10. Then all you have to do is plug this into your calculator. 60 over 36 times 10. And what do we get? 5/3. So that is equal to 5/3 pi. That's the arc length. The length of that arc. Okay. Well, we're going to find the ratio of the arc length over the radius. We're just going to make a fraction. We're going to take what we got for our arc length and put it over our radius. So again, our radius was what? I know this looks really goofy when you have a double fraction like this, but to simplify it, you can just do 5 divided by 3 divided by 5 in your calculator and change it to a fraction. Or you take the top number and the very bottom number, and simplify them. So what is 5 over 5 simplify down to?
1/3.
1. So they cancel, and it just becomes 1/3 tack on the top. So if you take the length, it's going to be inches. You take the length of the arc over the radius, simplify it down, you get 1/3 pi. Oh, we're going to do the same thing for this one. Find the arc length the same way. Well, the angle is 60, so that means its arc's still going to also be 60. So this step's still the same. Same angle, same first step. But the circumference is going to be different because we're dealing with a different radius. So again, 2 pi times your arc. So in this case, it's 8. Clean it up. What's 2 times 8? 16. Again, just like we did the other one, you just multiply that in your calculator. 60 over 360 times 16. 8 over 3. Tack on pi. And that is the arc length. The length of the arc. In inches. Okay? Yes, right. You can type 1 second. And check it with what we're doing here. So just like we did on the last one, we're going to take whatever we got for the arc length and put it over the radius. And again, our radius is what? 8. Simplify it just like you did on the last one. Plug in your calculator or use the shortcut. What does 8 over 8 simplify down to? 1/3 pi n. Good. 1, so we cancel out. Just because 1/3 pi. What do you notice? It's the same. What do you notice about the central angles? They're the same. We just found out what 60 degrees is in radians. It's 1/3 pi. Okay? Let me thinking, where the heck, why is pi so significant with circles? Okay? This might make a little more sense if we kind of know where pi comes from. So if you take any circle, it does not matter. I'm going to draw one. You don't have to draw this. I'm just demonstrating. You take any circle and draw in the diameter. I'm just estimating what the diameter is. Okay? And you took like a piece of string and measured what the diameter was. And then constantly wrapping that string around. The diameter goes around a circle pi times. That's kind of how they discovered pi. So we take a look at this diameter. I'm just estimating. The diameter would stretch 1, would stretch 2, stretch 3 with a little bit more. Because remember, pi is about 3.14 and so on. So the diameter of any circle wraps around it pi times. Any circle. Doesn't matter how big, how small, it's always pi times. Alright? That's where pi came from. So just discover this, they're playing around with strings and circles and figure it out. Well, let's take a look at half of a diameter. What's half of a diameter? Yeah, the radius. So we took the radius, okay, and we only looked at half of the circle. So we're taking half the diameter, we're going to look at half of the circle. The radius can go around a semicircle, half a circle, pi times. Pi times. 3.14, so 1 times. 3, 1, 2, 3, and a little bit more. That's pi. A little bit more than 3. So a radius can wrap around half of a circle, can go around 1. So if we measured the radius, it'd be like 1, 2, 3, and a little bit more. Can fit around a semicircle. And it does not matter any semicircle, any radius. That will fit. So if we can say a radius can wrap around a semicircle pi times, well, what's the degree of a semicircle? How many degrees is a semicircle? 180. 180. We can say a semicircle is 180 degrees, and we also said a semicircle is technically pi, because that's how many times the radius can go around it. Okay? Well, let's take a look at that fraction. 60 degrees is what fraction of 180? 60 over 180 simplify down to? 1/3, right? Okay, so we know 60 degrees is 1/3 of a semicircle. But we said semicircles also pi. So in radians, 60 degrees is just 1/3 of pi. Right? That's kind of where it comes from. You don't have to necessarily have to worry about where it comes from. It just might make more sense knowing where it comes from. Okay? What you have to worry about is converting. Because what a radian measure is, on a long-handed way, is what we did here in this example. Here and here. We found the radian. By finding the arc length, dividing it by the radius, gave us the radian. That's how you find it. Okay? That's a lot of work. And you might not be necessarily given the circle. You might not necessarily be given the radius. Okay? So there's a more short-handed way to finding the radian angle measure of an angle. Okay? What you can do is use these conversions. And that's where pi and 180 come from. If you're going from degrees to radians, all you have to do is take the degree and multiply it by pi over 180. So we could have, instead of doing all this work on the front, doing all this work here, to figure out the radian measure, we could have just taken 60 degrees and multiplied it by pi over 180. And still got the same answer. Because when you do this, you kind of ignore pi and just focus on the numbers. 60 over 180 simplifies down to what? What did we say? 1/3. And then you tack on pi. Same exact answer that we got on the front, doing all that work, finding the arc length, and dividing by the radius. Here's the shorthanded way. And that's what we want you to know. We want you to know how to convert. Just by doing that. Okay? What if we we're given the radian measure? So let's say on the front we were given, hey, here's 1/3 pi radians. We want to know how many degrees is that? Oh, you just flip-flop it. Flip it. Multiply by 180 over pi. It's really nice when you do this, because you notice there's a pi at the bottom. Actually, there's a pi in the top. What happens to those pi's? They cancel out. So then all you have to do, you just ignore the pi's. Just do 1/3 times 180. And 1/3 times 180 is what? 60 degrees. Okay. So instead of doing all that work that we did on the front, found the arc length, divide by the radius, just know these conversions. Okay? And that will give you the radians, and you can do them backwards and find the degrees. Okay. Questions over that? Okay, so some examples. We want to know how many radians is one complete circle. Well, how many degrees is one complete circle? 360. So if we're going from degrees to radians, what do we multiply by? Right off your paper. What is it? Pi over 180. So degrees to radians, pi over 180. And again, you just ignore pi. We want to leave things in terms of pi. You don't have to worry about it. You just have to focus on the fraction. So you just, in your calculator, you do 360 divided by 180. What do we get? 2. So that's equal to 2. Tack on the pi. Done. 2 pi radians is one full circle. Questions over that? Degrees, radians, multiply by pi over 180. All you have to remember. Okay? Make sure you write the word radians too. I put degrees for degrees. Write the word radian. Okay? Radians, you're always going to have pi in your answer. Think of it. Okay? Well, we want to know how many degrees is 1 radian. Okay, well, 1 radian is 1. If we're going from radians to degrees, what do we multiply by? Again, it's at the top of your paper.
1/3 pi.
What?
1/3 pi.
Well, look at the formula.
What is it? Look at the little formula. It says degree to radians. Tells you to multiply by what? 180 over pi. Those are just examples we did. 180 over pi. So really, you only have to remember degrees to radians is pi over 180. And just know if you're going the other way, you just flip it. So we're going the other way, so we just flip the fraction. And it's really nice. We want to answer in pi form. Yeah, we're doing that.
also, too, guys, this is on your formula sheet. So you have that. If you look on the front page, it's right there in the middle. It's kind of isolated by itself. Has no rhyme or reason there, but there it is.
Middle, right there.
The one that's got the conversion chart. It's in there.
Tells you 1 radian is 180 degrees. So radians degrees, you multiply by this. If you're going the other way, pull back. Yes. Yes. So then, all you have to do, plug that in your calculator. You literally are going to do 1 times 20 divided by 5. Okay. So you're literally just going to do 1 times 180 divided by second. Right? And practice this in your calculator. When it comes time for your test is on Wednesday, and you have a question like this on your test, I don't know how to type this in my calculator. Give me out of luck. We're not going to tell you. This is your time now to figure out. We're happy to help you now. On the page of the test, it's your time to know how to do it. Okay? So make sure you're practicing now, typing it in. If you're not getting what we're getting, make sure you're raising your hand so we can help you. So
Everyone should be trying this. The moral of the story is. The calculator shot, we're not basing you. Put your fingers on there, try it out. Because if you don't get the answers we're getting, there's an issue. So try this, ask us. There's 2 of us floating around.
1 times 180 divided by 5. You should get this. If you're not getting this, make sure you're raising your hand.
Especially the moral calculator folks. Casio's, some other form.
Good question.
Yes.
What do we do from here?
So use round linears 10 diameters so the directions will say. So 1 radian is the equivalent to 57.3 degrees. If you're not getting that, you're raising your hand. That's more questions. We want to convert 30 degrees into radians. So if we're going from degrees and we want radians, what do we multiply by? Pi over 180. Again, you just ignore pi. You do 30 divided by 180. And make sure you keep your answer as a fraction. Radians, we keep as fractions, and pi is in our answer. So what is 30 over 180 simplify down to?
6.
1/6. You just say 1/6, tack on pi. And then make sure you write radians, Irina. What's the radians? That's like saying an object is 6 inches long. Okay? Same thing. Just saying this angle is 30 degrees, but it's also 1/6 pi radius. They're equivalent. They're just in different terms of measurement. One more. We're going to see how many degrees is 30 radians. Well, if we want degrees, so we're going backwards, what do? What do we multiply by?
180.
180 over. And type it into your calculator. 30 times 180 divided by 5. And you should be getting a really, really big number. You're not getting a really, really big number that looks like that. Just gotta make sure you're raising your hand. So 30 radians is 1,718.9 degrees. watch this open. And you just need to know how to convert. So degrees to radians, pi over 180. Radians to degrees, 180 over pi. That's what you need to know. You just need to know how to convert.
And it's on the board.